So, you guys have to work together so you can join a team. So one of you go join Zoe and one of you go join LaShawn. And we're going to do a couple of different experiments. So first of all, I want you to hold on, video. Did anybody know how to make the video actually take a full screen so you can see like the whole video on feed? So anyway, but that doesn't matter because you're in class, so you can see it well anyway. But just take these numbers that I give you. Each of you has 30 numbers. So what I want you to do is to look through the 30 numbers and pick the smallest one and then lay it down to the very left corner of the thing. So make sure they're not sorted, but they're not sorted right now, are they? They are sorted?
I organized them. Try to unorganize them.
Yeah, so shuffle them again. So shuffle them as well as possible. So you're an overachiever already. You meant to anticipated the goal. So look through the numbers. One actually what would be even smarter is instead of having them all face up, just pick one of them up at a time and then until you get the smallest one that you have. So look through all your numbers, whatever they are. Look through them all until you find the smallest number that you have. And then put that one first. Now we don't know what the smallest one is going to be because we all have random numbers. Okay, so I found my smallest number. I'm gonna put it down. Okay, so I put down my smallest number. Then look through them again and find the second smallest one that you have other than that first one. So this is going to take a little bit of a while. No, just the smallest one. Find the very smallest one and then put that to the side. Like we're gonna try to get them in order, but we're gonna start by finding the smallest one, and then put that one down to the left or whatever, and then look through them again and find the second smallest one. Okay, I think I found my second smallest one. Put that one down. And then now look through them again and find the third smallest one. Yeah, I found my third smallest. Well, this is that. The thing is, our brains are too smart. It's supposed to show how hard it is to do to look through a bunch of things. But my brain can just like look through them all at once and just like find this small. But now look through them again. Find the next smallest one after the third smallest one. So, okay, so I believe we found it. Oh, this is too easy for my head. Okay, then find the next smallest one. Okay, so I think I found it. Now find the next smallest one after that. So if you're on the internet, you just make sure you have 30 numbers cut out from the page randomly out of all 100. Okay, there we go. Found my next one. Now I'm gonna find my next one. Okay, I found my next one. And we should have started a timer, but that's okay though. Don't worry at all. Okay, then these numbers also too flimsy, they're too small. I should have done my card just like that. And oh, I just realized I got one out of order. Have any of you accidentally got one out of order? Okay, then let me put this one in order. Okay, there, like that. Then, by the way, when you get something out of order for a human, it's easy because you scoot it over and you put it in place. But if something gets out of order on a computer, the computer has to copy and shift the entire block of memory over. Just to insert one thing in between. Okay, so I'm continuing to look. Okay, got my next one. So is anybody all done yet? Yes. You're all done? Okay, good. So you're done with all 30, right? Okay, perfect. I'm still working on mine. How about you, Zoe? Are you doing again? The second, you were actually the first one, but you're up.
We turned it all upside down, and realized that was really bad.
No, actually, that, so for our lesson, that's actually a good thing to do because the point is, it's just, we're trying to simulate a computer right now. A computer can only look at one thing at a time. Like in one processing cycle, it can only like compare or look at one thing at a time. So it's actually, a computer isn't able to just like look at all the numbers at once. Like my brain is just looking at these all at once. Sometimes it makes some mistakes of, but it's scanning through them all at once, basically, and then trying to find the smallest one, which is not really an accurate way that a computer works. 64, 65. At this point, it's just basically 67, 66, oops, 66, 67, 69. You'll notice once you get close to the end, it's just kind of easy and stuff, right? 72, 75, 76, 77, 78. Whoops, I got that. Oh, 74 was, you got one out of order. 74. Oh, it actually is showing these. Okay, that's cool. Okay, I think on the recording it actually is showing my work. 77, 79, 84, 85, 86, 88. And I think some of these were actually stuck together. They probably weren't quite as randomized as they should have been. Okay, there. So I'm done now. I didn't really put a timer next to it, but I still finished though, right? I don't know why that screen is not showing the. Hold on, let me.
I think it's just because it's your screen. I think usually your screen is smaller.
Still put that in. Yeah, maybe. Oh, well, yeah, because on this one, finally on this iPad, it got bigger like that. So hopefully on the recording, it's actually showing that screen and not that screen. Okay, well, now that's so I want us to look and study what we actually did. So I'm going to share a different screen real quick. Okay, so let's talk about what we did. You already kind of know what we did, but let's talk about it scientifically now. So view. Wow, why is that not still full screen? Alt. Okay, there we go. So what we did is something called the selection sort. The selection sort works better for humans than computers. Selection score basically scans through all items. I'm going to put in items to find the smallest. You could also do it backwards and find the biggest at first, but without lots of generality, we'll just assume that you find the smallest one first. And sets that aside. Or basically sets that one down first or whatever. And then you repeat and scan through n-1 items to find the remaining smallest one. So it's really the same thing because you just eliminated one, so then you find the smallest one out of what's left to find the remaining smallest. And then you set that one down next. Set that one down next. So then you have the first two put in order. So then you keep on doing this and you're selecting the smallest one out of the remaining ones every time. Now notice how many, so this is called an algorithm. Algorithm. This is an algorithm. So let's calculate how many steps that takes. The amount of steps, you can count how many steps are in an algorithm by looking at how many things you had to do. So it's n steps to do the first step plus n-1 plus n-2. So every time you select the next smallest one, you have fewer steps to do, right? That's why it takes the longest to put the first one in order. Then as you're getting close to the end, it goes faster and faster and faster and faster. until it's very fast at the end. Okay, so what point is the time at which you reach the last step, though? What point of time do you reach the last step?
You've gone through all the items.
Yep, and that happens when there's only one step left, right? Or when there's only one thing to look through. So when you find the very last item, you just look at it and you set it aside. It just takes one step. So what's the total of n plus n minus 1 plus n minus 2 plus 1? We've actually learned this already. What's the total of that? One plus they're n. Yeah, n times n. You said 1/2 times n plus 1, right? Yep. So that's how many steps it takes. So that was pretty easy to figure out, right? So that's the complexity of the selection sort method. Now I want us to do to try sorting these things again, except this time though, let me stop sharing my screen. This time we're going to do a different sorting method. So clear and stop. Okay. Now I'm going to, okay, good. Yeah, there we go. Perfect. Okay, good. All right, now let me make sure it's still recording. Okay, so this time, this is terrible. I don't know why. I don't know why this thing is working like this. Hold on, let me try something. Close tools, share. Maybe if I copy maybe if I do this. Hold on. Participants, copy invitation link. Okay. I'm actually going to close Zoom on this computer real quick for a second, and I'm going to try